Hi, it's Miss Cat, and I want to welcome you to Fun with Functions. Functions are kind of fun because they're kind of like mystery rules. We don't know what the rule is, and sometimes we have to solve it. Other times we are given the rule and we have to solve what goes in the output. So let's get started with some problem solving. So in the first type of problem, I'm going to actually tell you what the rule is. Now, in a function, the rule has to apply to the entire table. So whatever the rule is, it has to be the same for the whole table. So my rule today for this first function is going to be 4x. And what that means is whatever x is, I just multiply it by 4. So let's say that x is 0. I would pretend that the 0 is here, and I'd get 4 times 0, which we know is 0. And I'm actually going to move the 0 down 1. I'm going to leave a blank on top for the end. So now let's pretend that x is 1. If x is 1, we get 4 times 1, so our output is 4. Now I want you to think about, if we have 2, and our rule is 4 times x, and x is equal to 2, what do you think the output is? All right, I hope that you said that it would be 4 times 2, which would be 8. Now, I did leave a space at the top. I'm going to throw a negative in here. And if my value of x is negative 2, I would get 4 times negative 2, which would be negative 8. So next week, you'll be learning about graphing these. You are already super great at graphing, but what we're going to be doing is solving these functions and then putting them on the coordinate plane. So that's why it's really important to practice your functions. Let's try another type of function. The last one we just multiplied, but this time our rule is going to have 2 steps. So remember that the rule has to apply to all of the different rows in the function table. And our rule this time is going to be 2x plus 4. So whatever x happens to be, we're going to multiply it by 2, and then we're going to add 4. Let's start again on the second line with 0. If x is 0, 2 times 0 is 0, plus 4 would be 4. So our input would be 0, and our output would be 4. Now let's say our rule of 2x plus 4, let's say our input is 1. We would get 2 times 1, which we know is equal to 2, plus 4, which would give us an output of 6. I want you to try the last two on your own. And at the top of the chart, I'm going to go back again, and I'm going to add negative 2. And at the bottom, I'm going to add positive 2. And if you want a challenge, you can try positive 5 or 10 or make up your own number, whatever you want to do. So pause the video and then come back to check it. All right, welcome back. So if we have a negative 2, 2 times negative 2, we know that that equals negative 4. And then if I add 4, the second part, I get negative 4 plus 4 is equal to 0. So when my input is negative 2, my output is 0. Let's see what happens when my input is positive 2. So 2 times 2, we know, is equal to 4. And then plus 4 more, our output is 8. If you tried a number like 10, 10 times 2 is equal to 20. Plus 4 is equal to 24. So here, again, we have all of our inputs on the left. Those are equal to x. And then when you're graphing it, our outputs, which are over here, are going to be your values that are equal to y. More on that at the end of the video. The next type of problem that I want to show you is when you have an input and an output, but you don't know what the rule is. So an example would be, Let's say I have an input of 0 and an output of 3. Then I have an input of 1 and an output of 4. I'm going to do an input of 4, an output of 7, and an input of 5, and an output of 13. So the first thing that my brain might try to do is find a multiplication pattern. Like I know here that 1 times 4 is equal to 4. So that would work with a rule of times 4. But if I do 0 times 4, it does not equal to 3. So it doesn't look like I can just do multiplication. So the next thing I might try to do is just addition. Okay, 0 and 3, we added 3 here. That works. 1 plus 4, we added 3 here. That works. 2 plus 3, ooh, that's not 7, so that does not work. And 5 plus 3 is 8, not 13, so that doesn't work. So I know that plus 3 works for some of them, but I know it doesn't work for all of them. So I'm going to see if there's something that I can multiply, so like times blank plus 3, because I know the plus 3 works sometimes. Times blank plus 3, times blank plus 3, times blank plus 3. All right, so if I did 2 times something plus 3, so if it was 1, 2 times 1 is 2 plus 3 is 5. If it was 2, 2 times 2 is 4 plus 3 is 7. So it actually might be the number times 2 plus 3. Let's see if that works here. 5 times 2 is 10, and then 10 plus 3 is equal to 13. So it looks like I have solved the mystery function. Let me just fix that 5 here. It looks like whatever number I have to take that number and multiply it by 2. And then after I've done that, I have to add 3. So if the number is x, we would write that as 2x plus 3. 2 times the number plus 3. So for example, if my input was 10, I would have 2 times 10 plus 3. 2 times 10 is 20 plus 3. I would get an output of 23. So I would have solved the mystery rule, that the mystery rule here is 2x plus 3. And remember, that has to apply to every single row. It can't just work for some, it has to work for all of them. So let's go back to our first slide and look at how you're going to be using this next week with graphing. So you know from all of your experience with graphing that sometimes you see ordered pairs with a number like this and a number like that. And other times you see tables like this with x and y, and there's numbers in x and numbers in y. So we can write our functions table the same way. So we're going to start with our first input of -2, and the matching output was -8. So I can write this in a table as -2, -8. I can write it as an ordered pair as -2, -8. So either way I write this allows me to put it on the graph. Okay, next up we'll have 0 and 0. So when x is 0, y is 0. So our ordered pair would be 0, 0. 2 more. You can pause the video if you like and see if you can fill them out on the table and write the ordered pairs on your own and then check back, or you can just stay with me. When x is 1, our output is 4. So when x is 1, y is 4. And our last one, when x is equal to 2, our output is 8. So again, you can write your ordered pairs to put on your graph either like this with each ordered pair inside its own set of parentheses, or you can make a table like this, which shows how each x value matches up to a y value. This will allow you to do our work next week of graphing. Thanks for joining me. Hope you have a great